Hey, what's up guys? Welcome back to the channel. It is finally time for a blower door test here on The Best House. Now, that big red door cover there, that is the blower door, and that was brought down by Jake. Jake is from the Energy Conservatory, also known as the Minneapolis Blower Door. Like, that's your guys' product, right?
That's the thing, yep.
So, awesome. I'm really happy that they came down, and that's thanks to Randy. Randy, you were here for the last blower door.
I was.
It was awesome. We had a great score. But this house is completely different. It's different mainly because of this guy right here, which is Dan Edelman with Rockwool. This house is completely done with Rockwool and then Siga Myrex. So I wish Etienne from Siga could be here for this. But in the other project, it was all spray foamed. My opinion, it was a great air seal, but it's kind of the lazy way to do it. And maybe it won't be as good 10 years from now. I don't know. So guys, I'm excited to do this. We've got it set up. Let's go ahead and do a blower door test. All right, like I said, this is Jake. Jake, thanks for coming down,
no
man.
problem,
First time we met. And tell me exactly what you got going here and kind of give us the lowdown on what you're going to do.
Cool. This is the Minneapolis Blower Door system. It uses a 2-channel manometer here, very accurate to measure the pressure between the house and the outside. And the second channel here measures a pressure down in the fan. And we convert that with the size of the ring to a flow. So we can use this to measure how leaky the building is.
Okay. All right, so first test we're going to do is just a simple turn it on, and you're going to try to get to 50 pascals between the two?
Well, and I can show you just quickly here how tight this is when we start to turn this guy on here, I can go nice and slow, and if you watch this channel here, go up to 50, just to show how tight this building is. You know, I'd normally grab this and just turn it up a little bit.
Are you saying because it's you're forcing a ton of air right away and it doesn't have a lot of places to pull from?
Yeah, it pressurizes very, very, very quickly.
And for the people in the camera, here's your pressure difference between inside, outside, and there's your fan CFM.
So here's this overshoot. I turn it up to kind of where I normally would turn it. Boom, yours jumps up to 80.
Okay.
So I'm gonna be dialing this back down if I was doing a manual test. You hear the fan slow down. So just as a really quick check when you walk in the door, you know.
Get a feel for what you got.
Yep. We're going to be somewhere kind of in this 330, 350 range.
Okay.
So that's just a quick gut check there. I'm actually going to use our app though to run an automated test. So this will get you a little bit better data. And it actually uses an app to Bluetooth connect to the gauge. And actually the whole test is run from the app.
So just for a reference, code here by us is 4 ACH, which means that by code, you're supposed to have a house tight enough that it will only exchange or somewhere less than 4 times the volume of air in your house every hour. So obviously 4 would be code, but we don't want to be 4, we want to be much lower than that. So I'm excited to see where we come out. For me personally, my goal is sub 1 ACH. Now, the last house we did, that was like 0.4 or something. But you got to remember, you're talking about air volume exchange, and that last barn door was probably, I don't know, Randy, was it 3 or 4 times the volume?
Somewhere in that neighborhood, yeah.
So it's going to take a lot more air leakage in order to pass all of that volume through holes. So if that makes sense, the smaller the house, the harder it is to get a low score on the blower door test.
We've got the gauge connected here with Bluetooth to the app. So I'm actually going to be able to just start the tests from the app here. And so this will actually do a temperature correction. So when you're doing a blower door test, knowing the inside and outside temperature is something that you got to take into consideration.
And why is that, Jake?
So the density of air. If we do this test in the winter versus in the middle of the summer, the same building is going to have a slightly different answer because the density of the air changes. So what do we got for an indoor temperature?
It's like, Greg's right behind you. What does that say? 62? 66.
66. What are we doing for outdoor?
Probably 81.
Oof, good.
Is it 81?
I'm just happy that it is 81.
Oh, yeah. Well, yeah, you're coming from Minneapolis.
Long winter. There's actually a altitude correction as well. All right, so we'll fire this up. So the app will start. Gauge is now in remote control mode. So this is just passing signal through to here. So now I'm taking a baseline, which is measuring how windy it is outside.
Without the thing on? Okay.
Got it all capped off. So baseline's done. And then the app prompts you to uncap the fan. And we're going to use ring B on this because we're assuming it's pretty tight. And hit continue here. All right, so we're using ring B here. And so now the fan will start. App is going to adjust up to 60 pascals. So we're going to take multiple data points and snap a line of best fit across it to give you a more accurate answer.
Okay.
So in a really tight building,
Goes and overshoots it.
overshoots it, right? So this is kind of set up for a typical leaky house. Let's get the fan turned up, get it up to pressure. I can tell right away without even seeing the number, this is going to be a tighter house. So fan will dial in here to 60.
And we're depressurizing,
Yep.
so we're drawing air in from the outside.
Yep, correct.
So does it like sit around 60 for a certain amount of time,
Yep.
and then?
Yep, dials in there on a windy day. The wind's going to be pushing that pressure too as well. So the fan's got to.
It's always windy here, dude.
Yeah, it's got to adjust for that. So now we've gathered data there at 60 pascals. Now we're going to ramp down to 48. So it'll slow down. And this is the beauty of using an app to control stuff.
For sure.
Is, you know, I could manually turn that down, but we're using an algorithm in there to take a bunch of data to really dial it in there. So it's essentially like you're taking many, many, many blower door readings individually
Okay.
and summing them all together. So the thing that's going to happen here is we drop down to a lower pressure. Our flow is dropping as well. So at some point with something this
Might
tight,
have to change to
I'm going to
C.
have to change to a smaller ring probably.
Will it tell you automatically?
Yep. So this thing's so tight that I'm feeling this one or the next pressure will be at a different ring. Yeah. So update the flow ring. So,
Okay. So it's not that you have to redo anything, it just is basically saying, go ahead and do this, and then you'll hit start again.
Exactly. Yep. And these rings are used to keep the fan accurate as you're doing really, really low flows.
Okay.
So the geometry of those is to keep the pressure at a high enough range right around the sensor here.
Okay.
So hit continue. The app knows that we switched rings, so it'll auto update the ring. We'll bring it up to pressure now. And now with a smaller volume, the fan will have to pull harder, keeping the pressure high right around
That makes
that
sense.
flow sensor. So now we're getting dialed in. 23 there's our target pressure here. So it's zoomed in, now it'll sample. So when it's sampling here, it's taking hundreds
of little...
just tons of readings. Here's our last data point there. And just like that, boom, report. So,
Okay, so this is going to give us the number.
yep,
This is the red blower door
so
of truth.
you're 1.03.
Okay.
All right, 4 is the pass, so you're well over that.
But we didn't hit under 1.
Is that right for volume?
I don't know.
So we can check that. You're right on the edge there.
Randy did the math on the volume, so. I mean, one was my goal. Like,
Right.
I want to be 1 or less, obviously.
Well, and you know, there's a lot of additional data on here. The correlation coefficient here, this tells me that it's kind of windy. This
Okay.
is, you know, so in a situation like this where I was that close on a windy day, I might run this again.
So now that we have this data, though, I mean, the main thing was, I know there's some spots that I didn't even seal up because I wanted to have some data points, you know? Now what can we do? We can turn this thing around, or what's the next step?
Next thing I would do to diagnose is I'd flip the fan around and pressurize, and we could just manually turn it up to 25 or to 50. We just want to get a pressure in here, and then walk around with a fog puffer, and we'll look for some specific spots that you think might be an issue.
What was the CFM?
408.
Oh, was that high? I thought we were down around 300.
Well, and this is the nice thing about the graphs. So when you take all those data points, it snaps a line of best fit there, and this correlation coefficient, if that's 0.99 or higher, you've got good data. I like to see it higher than that.
Where are you at?
It was 0.992.
Okay.
So I'd like a little bit higher, and then what that's saying is how close do all these fit on that line? That one right there is a little bit higher, that one's a little bit lower. That's why I'd want to redo that, because we had some wind. So we're fighting with wind, and that is potentially going to change that a little bit. So let's pressure.
Pressurize it, find some leaks, hopefully, and
Yeah.
and then we can run it again.
Yep, let's do it.
Yeah.
8.2 inches squared.
13.2 inches squared. That's not many leaks, dude.
No, and that's the thing.
So, I mean,
The battle below 400 is, I mean, you're fighting for tiny, tiny, tiny little leaks.
yeah,
at
but
that
13 square inches, isn't that like 3 times 4? That's like a 3 by, I mean, basically it's 12. Threes, yeah.
Yep.
Oh, okay, yeah, we're gonna have a hard time finding that money, I guess. Greg, time to become a detective.
I guess.
We gotta get below 1.
So the 3.4, 3 by 4.
Yep.
Now we know a couple of leaks.
Well, I know for sure I got this door here. I don't have the little fuzzies that go in the corner.
Yep.
This door right here has leakage right here.
Yep.
We've got a couple pipes over here that haven't been taped at all.
Okay. Now how big are those pipes?
Well,
Half
I
inch?
mean,
So you got a half-inch hole right there that goes outside. We'll do some investigating and we'll figure out where that's at.
well, that's the big thing is I didn't want to just come in here and be done. I want to be able to say, okay, you miss a pipe like that, it equates to whatever, you know. I would think that these would be, it's got to be sucking something in, right?
Oh yeah.
Yeah. What about the one below you? The gas pipe, all the way down.
Oh.
That's a huge leak, man.
It's a huge
That's
hole.
a huge leak. For this site, for this building?
Put that one right behind you.
Oh, what about this one, Dan? Try this right here.
Not in.
See,
Or
that
just
one's,
a ladder?
that one's not too bad because that's sealed on the outside.
Ladder, you want that?
Yeah.
Still leaking.
That's your LP. Exterior.
Well, see, this goes through a column and it goes out to the Weather Logic, so really it's basically sealed with lumber.
Right.
So it's not insulated around that pipe. We could shoot some, you know, expandable foam in here, but
Or tape.
it's taped and sealed on the Weather Logic, so we're at least using the exterior air and water control layer to. Yeah, did you see that down there? That's pretty good.
Yeah. So this is
Huge?
that's enormous. So and here's the value of having something that doesn't just blast smoke, you know, out. You want to be able to have a small bead like that so you can really dial in on where the leak is. Yeah.
Look at
same
that.
thing. That's huge.
Yeah, we're gonna fix those.
Yep. Okay. So
So we don't have those little fuzzies. It didn't come with, like, you know, like,
yeah. So yeah, I mean, if
it's not horrible though.
If I do this and blast it across, you can't tell what's going on,
Yeah.
right? So if you get, and I can see daylight. So,
I know.
So,
Yeah.
so, but if you get a controlled bead like that, I can see it getting drawn in a little bit. But this,
You're also getting wind pressure outside though on this spot.
they're fighting. And compare that where I gotta really dial that smoke in.
Yeah.
To just like
That just
getting
sucks.
it any like I can't get it to go anywhere else.
Yeah, it just sucks in. All right, so this is for my electrician. He did this for us once he punctured into the garage, and he taped it. So I just want to see how good he did.
Give it a little more.
So what do you think about that, Jake? I mean, it's definitely not bad.
No, it's not.
Oh, it is sucking in pretty good right here.
So if you can get the smoke to go across the hole,
Yeah, you
that's
show me.
typically how you can. So that's not going in.
That's not bad.
No, and that's no. I would call that one good. I don't see it getting sucked in, right? So
he did a pretty good job sealing his penetration.
Yep. I'd agree.
All right,
I'd
Greg,
agree.
we better let Harry know he did a good job. Nice. All right, so here's another thing that we actually seen early on. Randy and I think we looked at it at the same time, actually. We've got our Myrex taped up here, and I see that the tape has fallen away because we didn't do a great job. So is that an air leakage point there, Randy? Oh, yeah. Okay. So the good news is we're finding spots.
Yeah.
So we might be able to get that number down below 1 with a little bit of work. Also, we've got some conduit that's going to the outside that Dan here found. And this is something that people don't necessarily think of, but we've tape sealed the conduit, but
fine.
it's still going, the conduit is empty. It's hollow, so it's still open to the outside. What do you got? So look at that. That conduit runs outside, so we need to do a little bit of sealing right there on that conduit with some putty or something that can be removed later. So it's good to find all these little spots.
We're not seeing a lot through here,
Yep.
but right at this spot here.
Yeah, I see it coming out the outside.
Yep.
So what can you do about that, though?
That not much.
I mean, that's the, but I think we've talked about this, Randy, and I've had conversation with other builders. Like, you can spend a lot of money on windows and doors, but you can also get a good enough door and window. And if you spend all the time and effort on all the details, you're not relying on a really high-end door and window. I know people don't like to, tell customers that because you like to get the good quality stuff.
And Steve Basic, his famous comment is, something's always got to be the worst. No
Yeah.
matter what, there's always, something's really good, but there's something that's always really bad. So
And windows and doors are always the worst part of your assembly.
they have to open.
Yeah, and yeah, there's joints. So, all right, I guess it's time to start maybe doing some air sealing, and then we can run this blower door again and see how we did.
What's this smoke made out of?
Surprise!
It is pretty amazing. You brought that last time, right? We just didn't use it. Yeah.
right, should I have everyone go out and then real?
You just got to set up the dial, turn it up. You got to set up the Pascal so I can see.
Yeah.
All right, guys, we got this thing smoked up and we are ready to go outside. We're gonna pressurize the inside and see how much smoke comes out so we can really track down any of those air leakage points and fix them.
So it'll take like, what, 8 minutes?
To get rid of it all. See, he sealed this. So that's what I'm saying is that hole is going somewhere else.
Into your shell.
Well, this isn't sealed right there though. This runs through to it, right? Like it's just on the other side.
Oh, good point. Yeah, it could be coming out right here.
Coming out right.
Yeah, that's
Can
possible.
I climb up this?
Sure. Ain't gonna hurt nothing.
Talk about post frame right
Yeah, you just got a ladder all the time, man.
Yeah, it'll come out up here, I bet.
All right, I'm not 100% sure, but we might have some air leakage up here on this porch. I mean, this is an all-weather box. I don't know if you're gonna see anything. I think it would probably, I mean, it's all sealed, so I don't see anything. No. You're not gonna see anything here either. It's a closed box.
Each one of these techniques does have some downfalls.
Well, when it's super windy outside.
Yeah, exactly.
We know that this one was leaking because Dan tested it, but that doesn't mean we can see anything. What about this sliding door?
Yeah. So Kyle, it's a.
Oh yeah, okay.
Well,
Look at this. I mean, this is a fixed door here, and it's still coming out right here on this seal. That I could probably put some sealant in, white sealant. You would never know. And maybe honestly, even here, this is just the manufacturing of the door, right? I mean, this is not a sliding piece. There's no reason for this not to get sealed.
Hey, man! Let me squirt the top of the window, see if you guys can see anything coming out.
Oh yeah. Double hungs. All coming out there.
That just increased from the last time that we were, right?
That's because he's shooting it directly
standing
now.
there blasting it with the.
Oh, okay.
So it's
Got
a
it.
density of.
That's pretty major.
Yeah.
Yeah, right now that's just got like free clearance to go anywhere.
Yeah.
Cool. I think I've seen enough to seal some stuff
Let's
up.
go seal them. Yeah.
All right. If we can see inside even. Holy cow. Man, they've really smoked this place up. But the good thing is, we now know where a lot of our problem areas are, which is what we wanted. And now we can fix them. We're gonna get this all cleared out, fix our mistakes, I guess, our penetrations, and then we're gonna redo this blower door test, see if we can get below 1. Well, above us, we gotta fix that for sure. Might as well do that.
And then it shuts off.
Right.
This was a horrible leak spot right here. And while we can probably push this tape back up, we're just gonna be safe and we're gonna add another chunk of Rasan. See, like I see this little spot right here could use maybe a little tape too. See if you can find any more. All right, we knew this was gonna be a problem area, but that's why we left it, just so we could have a good idea as to really what this amounts to. So if you do forget a pipe, what kind of result it can change in your blower door test. This is not an easy thing. It's gonna take a lot of little pieces, but it should work. You know, since Rockwool has great, I guess the density's so good, it doesn't allow air travel nearly as much as like a fiberglass or something. We're just gonna go ahead and, for the ease of in case somebody has to pull wires, these are the pipes that are going outside, and in case any air is obviously trying to get sucked through, this Rockwool is gonna slow it down, but my client could still pull it out of there if he needed to push some wires through. Good, okay. Okay, so yeah, we just realized that we missed like 20 feet worth of sealing up a joint with Sega. So there's a really good chance that we might be able to get a better blower door score just by taping this. So Greg, good eyes, buddy. Nice job. All right, man, thanks. I can't believe that, man. I looked around this place how many times to see where we needed to do something. And this is literally wide open into the garage. So garage doors open, this was just sucking air out.
I mean, you saw how much that little.
Yeah, how much air moved out of just that little pipe.
Yeah. So imagine this whole entire.
I'm
seat
surprised
and
we
this
even
seat.
got to a 1. Now I'm excited.
Yeah.
Okay, so we made all the fixes, and now Jake put a smaller ring on because ring B is too big of an opening for the air leakage that we had. We had some really dumb mistakes, guys. We totally missed some spots. Oh, we're gonna stay under 300? Oh boy, we're low 2s?
Wait for it. So that compressibility of air, I'm not turning that up anymore. So this is just the pressure finally equalizing through your
Holy crap, we cut it in
incredibly
half.
tight building. So now we're pressurizing at 60.
And we're still under 200?
And that's not the test pressure. We need to test at 50.
Holy cow.
So we'll slow this down. It's going to take a second in a tight building.
Now is this where, because it's so finicky, the test on the app would be the most accurate way?
Absolutely.
Okay.
And even now, I would actually go into the app and change some of the settings.
Do we need to change the temperature settings because we let all that hot air in too, or does that not really matter?
Yeah, that'll matter.
Oh, okay.
Yep, yeah. So I'll try.
boy.
You got a little wind here, so it's going to bounce a little bit.
Bounce around.
But
Have you already done the numbers, Randy, with the volume? Or not yet?
You're 1/4 what you were,
Oh, wow.
or roughly, maybe 1/3.
Like 0.3? Holy crap.
so you dropped it by over half, by 2/3.
And honestly, if we wouldn't have done a blower door test, there's
Yeah.
a 100% chance
Yeah.
I would have never even noticed those seams that we forgot, which were huge air leakage. We would have just let the drywaller come in and do their thing. Not because Greg and I are poor builders, because we're human, we make mistakes. And so this right here, that's why they call it the blower door of truth. It tells you everything you need to know about your air control layer. And wow, we dropped it huge.
You crushed it.
That's awesome,
Right?
man.
Yep. Good
Thank
stuff.
you.
Yeah.
Oh,
The air's being sucked back in. You know how rare that is?
I don't know.
I've seen it one other time.
Wow.
Have you seen it?
I have not.
So we've depressurized so much that it's like there's not enough air leakage to stay there. It needs to bring it back in order
Through
to
that.
equalize.
Yeah.
But normally when you shut that fan off, boom, everything just
Dead.
dies. It's like
Right.
everything drops to the floor. With
Wow.
this one, everything's got to go back through the fan to equalize back outside.
Well, this is all great, guys, but now we need to do an actual test so I
Yep.
can see an actual number.
Yep.
I gotta be honest, Kyle. I've been involved in 2 post frames now.
Yeah.
They're both incredible builds. I mean, I think this could be the wave of the future. And
Advanced framing, man. I mean, we're not special. We take time to do the details, but the details are easy because of the nature of the build, I think. And that's where really the benefit of post frame comes into play, and that's why we've constantly said that it's not that this is the best house, it's that in our opinion, it's the best way to build a house if you're looking for cost efficiency, energy efficiency. It's just a great way to do it, and I think that time and time again, we're going to hopefully be able to do these blower door tests and prove it. Just a couple dumb pole barners out here building houses, I guess. So
A cool feature here. It's windier than we did our last test. So the app sees that and it says, hey, we got windy conditions. Do you want to use Wind Assistant? So this is actually a feature that's built into the app now that's going to start looking at the variation and start to control the fan differently.
oh wow.
So it's basically, it's a way to kind of fight back against the wind a little bit.
Okay.
So it gets you better data in windy conditions
And how does it know that with that being closed up right now? Where's it measuring?
off these 2 sensors here. So in this case, it's looking at the pressure between the house and the outside.
Okay.
So it's looking at channel A, which we've got in the garage.
Okay.
So we just redid the baseline now with the wind assistant on. And I went in and made a change too because this is a really tight building. So the fan's gonna operate a little bit slower so it doesn't overshoot.
Okay.
And we'll start on ring C. Okay, so
Now, while this is starting up, okay, Jake, why would a builder want this? Other than to be able to puff your chest and say you did a really good job, what's the actual benefit to the builder?
I mean, code's probably, like, at the end of the day, that's what's going to make you do some of this stuff.
Okay.
But honestly, if you want to avoid callbacks,
Yeah.
this is a way to know exactly how your building's performing.
But I mean, doesn't that also help with like the HVAC systems? I mean, when you know
Yeah.
that you're going to be
Yeah.
at a 1 or lower or whatever, I mean, that's going to size the equipment totally different.
You've lowered your load.
Save money.
Yeah, for sure. Homeowner's going to like it better. You know, it's a little more work too, because you got to work with your contractor who's putting in your HVAC system, and if they size it with a big system, it might short cycle. So
Okay.
you got to do this and take the next step and work with your contractor to make sure they right size that system. So compared to last time, now this is taking a lot more data.
Okay. Because
So-
of the wind, or
Yep. It's yeah. So when the wind assistant's on, it's saying, hey, what's one way you can get a better reading? When you have windy conditions, you take more data. Take it for
you
longer.
can average more
Yep.
numbers.
Yep. It gets you
Does
better.
it throw out the really high numbers when the wind's pushing, or is it just average them?
I think it averages them. I don't know specific. I don't think it doesn't get rid of any data.
Okay.
It's because that data is all real data.
real
It's
data.
all happening.
Yeah.
It's just, I mean, if you, like when I started doing blower doors, I would just manually turn it up. And this would be bouncing around. I'd be like, and I'd pick a number, and I'm just guessing in this kind of sea of data. Oh, that's the number.
Right.
This is a lot better way to go about it. It's taking all the data, it's finding you a good average, take some of the human error out of it.
So this building you scored 166 CFM,
Yep.
which is awesome. Which ended up being what, a .43 ACH 50.
Yep.
But there's another metric that we can use to identify the air leakage of this building, and that is the CFM per square foot of surface area. So when we figure that, we're figuring the lid and the floor, so we're able to count the square footage of both. We know we don't have any leakage. Hopefully, we don't have any leakage
hopefully the
in the
concrete's not
concrete
leaking
floor.
air.
Yeah, and then all the walls, exterior walls, or walls that go into the garage. They're part of the envelope. And what you ended up with on that was .023.
Now
which is-
compare that to, we had a lower ACH 50 number on the barn door that you came down and did a test for us, was a .41
Yes,
ACH.
right. It's close, but just a little bit less leaky as far as the air changes per hour metric. But as far as the square footage of surface area, you actually got a bit better score, because that was, I think, if I remember right, .038 was that one, and it's .22 now, or .022. Gary Nelson, the godfather of the Minneapolis Blower Door, he brought up, I had a conversation with him, and he thought that .07, .075 would be the ideal spot for a house to end up. You're close to 1/3 of that.
Third of
with
that.
this house.
So even though we had a higher blower door score at 50 pascals,
Yep.
this actually has less air leakage per square foot.
Right, because when a house leaks, it doesn't leak in the volume; it leaks on the surface, right?
Right.
So that square foot of surface area is actually a little bit better. metric.
Interesting little thing. Okay, cool. Yeah, I've never spent this much time on an interior air control layer. What was our CFM?
CFM, you're now down to 169.5 and ACH 50 of .43.
0.43.
Yeah.
Is that, were we 0.44, Randy?
4.1, I think.
I think we were 0.44.
Was it?
I think it's the same. I think it was 4.3.
Oh, eh, it's still pretty good. It's a lot smaller house. No spray foam, so yeah. All right.
That's incredible.
Wow,
That's, yeah.
awesome, man. Thank you.
Yeah.
I don't know what's next then. I don't know if I could do anything better other than use different doors and windows. That's it.
Yeah, pretty much.
I mean, what's the next step, Randy?
That's pretty much it. I'd be willing to guess that's the majority of the leakage that's left is double hung windows and a patio door.
Maybe Romex to the outside instead of pipe? Would that make it easier?
It'd be easier, but you can seal the pipe.
Yeah, true. Well, to wrap this up, guys, I really appreciate Jake coming
Yeah,
down. That
was
is
awesome.
awesome, man. Minneapolis Blower Door. If you want to get a feel for what your builds, how they're performing, I mean, this is the ultimate truth.
Yep.
We've always felt like we've done a good job. This tells you if you're doing a good job, tells you when you're making mistakes. Randy, thanks for coming down, dude. Randy, Northern Built Pro on social media. If you got questions about anything building science, this guy's the man. Dan from Rockwool, he set this up. This whole building is Rockwool. That's going to give us all of our thermal, efficiency. It's behind the Sega. It's doing its thing. And then Chris is my local guy. Yep. Thanks for coming down, Chris. He's the local Rockwool guy. So you guys enjoyed this? I enjoyed the heck out of this. This is like the ultimate test. Tells you what you've done, how good you have performed. And honestly, for me, it's about just providing the best possible job for our client for the life of his building. So I think we've done that, Greg. Nice job, buddy. All right, we'll catch you guys on the next video.